Hello, my name is Jesse Short, and I am pleased to present network centralization and collective adaptability to a shifting environment. This is joint work with Ethan Bernstein at HBS and Alice Jayoung Jang, also at Boston University. I'll start with the definition of the key concept in this study, which is network centralization. Centralization is a network level, not a node level concept. It refers to the variance in the centrality of individual nodes. So the network on the left-hand side here is highly centralized because one node is highly connected to all the other parts of the network. It's in the center of the network, if you will. While all the other nodes are very peripheral. Well, the network on the right is not centralized at all because all of the nodes in this network are equally central or non-central. There's no variance in the centrality. So as a whole, that's not centralized. Centralization is a description of the network structure only, the way we use it, of who can communicate with and influence whom. Although it's been empirically confounded with hierarchy, status, and power right now, we're looking only at network centralization per se and not those other issues. Network centralization is empirically important. Digital social networks are highly centralized. For example, Twitter discussion is dominated by a few highly followed accounts. And formal organizational networks are also highly centralized, although the trend there is away from centralization toward decentralized organizational forms, partly because of a sort of concern that network centralization might be harming collective problem solving. So before I move on, I want to give you a preview of our conclusions. I'm going to show you that network centralization increases collective adaptability to a shifting environment, but only when communication goes both ways between the central nodes, the central individuals in the network, and the periphery. That's novel because prior research has generally shown that centralized networks are bad for collective intelligence for two reasons. The first is that the central nodes in a centralized network, the core is another way that we describe them, they're too influential. So if the central nodes happen to have a bad idea, then everyone's exposed to that bad idea. The other issue is that peripheral nodes, the ones on the outside of the network, they're kept apart from each other. So they can't integrate their ideas. If some of them have good ideas that they should be recombining with each other, they can't do that. Now, what we know from our own previous studies is that the effective network structure differs by problem type. And all of this past research that's shown problems with collective intelligence, it's tended to be of one general type of problem. It's a fairly broad class of problems, but a class of problems nonetheless, which we would call stable problems. The key challenge for this kind of problem is to use existing knowledge, to learn from each other, to transfer knowledge among the nodes in the network, or to put the pieces together. And examples have been project-based work or wisdom of the crowd. We are interested in a different kind of problem, where the effective network structure of centralization is unknown, which we're calling collective adaptation problems. And this other class of problems, instead of using existing knowledge, the challenge is to maintain diverse points of view and avoid locking in on some existing consensus so that you can adapt when the world outside changes. For example, right now, we are going through a period in which many organizations have had to go through a collective adaptation to a shifting environment because the COVID epidemic has made every organization reconfigure how they do business. And oftentimes the way they do business when they're over Zoom, just like this, can look very different from the way they did business in person. And so there's a collective adaptation problem there. Other examples would be innovation, strategy, and adapting to the way the world changes around you. Now, the study of adaptation, this kind of problem, has been intertwined with the study of contagion through social influence. When solving problems and individuals are uncertain about what to do, it's oftentimes rational to copy the solutions of the people they are connected to. Now, sometimes they copy bad ideas from each other, and then in that case, oftentimes that's described as herding. In other words, it's like so many sheep, people substitute other people's judgment for their own, and they can easily get stuck on a bad idea. On the other hand, in other circumstances, people copy good ideas, and we give that a different name. We often call that learning, right? I can learn good ideas from the other people who are presenting papers at this conference. Now, let's look at herding and learning visually by comparing the distribution of outcomes from people solving a problem separately from each other we'll call that isolates, this sort of group of 9 isolated individuals. And we're going to compare that to outcomes from people solving a problem in one big group, or we could also call that a complete clique in network terminology. Now here's an empirical cumulative distribution function, an ECDF, of the number of people correct per trial out of 9 on the x-axis, and the cumulative percentage of trials that achieve that number of people correct on the y-axis. So results from people who are isolated from each other show that the median trial has 3 people correct, the 25th percentile trial has 2 people correct, 75th percentile trial has 4 people correct, and no trial has any more than 6 people correct. Now, if we compare that to results from complete cliques, large groups of people who are all connected while they solve a problem, we see a very different pattern. Compared to the isolated solvers, the complete clique has many trials with 0 or 1 people correct. In fact, the median trial has only 1 person correct. So many trials where they get stuck on a bad consensus, but also on the other end of the spectrum, there's a lot more trials in the isolated solvers where 7, 8, or 9 people have the correct answer. So you have herding, which is a negative effect, and learning, which is a positive effect. They both are outcomes of the same mechanism, which is copying solutions of each other. Now, that's unfortunate because we'd really like to have one learning without the other, which is herding. Our previous work found one way that we could resolve this tension. And just again, to review that tension, independent nodes, isolated solvers, they're good at generating diverse ideas. The problem is no learning. Connected nodes, when people are in a group together solving a problem, they're good at using and spreading ideas. The problem is the risk of herding on the wrong idea. So in a study we published in 2018, we found that if you alternate between the two, if you have both together by going back and forth, you can actually get the benefits of both without the costs of either. You could generate diverse ideas and learn from them. You can get the learning effect without the herding effect. Now, returning to centralization, we reasoned that that same effect that we found might also occur in centralized networks. Centralized networks might also create the conditions for learning without herding because of the particular way that they structure social influence. In short, we argue in the paper that peripheral nodes are relatively independent from each other and thus should be able to generate diverse ideas. The core does exert conformity pressure on many people in the periphery, but only weakly relative to other empirically common network configurations. So in short, we argue that centralization should create conditions to limit herding. We also argue that the core should be able to learn from those diverse ideas in the periphery and spread the good ones to the rest of the people in the network, because the core has a very privileged position where they can see diverse ideas from the otherwise disconnected peripheral individuals. So we argued that centralization creates the conditions for learning. But both of those mechanisms only work if communication goes both ways between the core and the periphery. Otherwise, neither one of those effects will occur. Just for reasons of time, I'm going to keep it at that level of detail. Of course, the paper has much more detail, and I'm including a link at the end of the presentation for anybody who's interested. So to test these ideas, we ran an online laboratory experiment. On the right-hand side, we see the network visualizations we tested. There's the hub and spoke and the core periphery network, which are centralized networks. The next row includes 3 different decentralized networks. There's isolated nodes with no connection between them. On that other end of the spectrum, there's the complete clique. And then also a locally clustered network, which is an intermediate density, also totally decentralized network. We also tested 2 directed versions of the core periphery network because we are interested in identifying the mechanisms through which centralization works. And we chose one that has outgoing ties from the core to the periphery and one that has incoming ties from the core to the periphery to the core, excuse me. We randomized subjects into those 9 node networks in which they could communicate, share information, and see peer solutions to the problems. The goal, of course, was to test the effect of these network structures on a problem requiring collective adaptation to a shifting environment, where they had to shift from one incorrect consensus to a correct consensus. So how do we do that in an experimental setting? We gave them a murder mystery in which the early clues led them to the wrong answer. So they would generate a consensus that was incorrect, and only later did we reveal clues that would lead them to the correct answer. And of course, we wanted to test which one of these network structures did best in adapting to the shifting environment. We used a custom-built interface to run this experiment. There's sort of three parts here. On the right-hand side is a search functionality. People could search for clues to the mystery with keywords. They could share those clues with their peers and then send free text messages, reply to each other's messages, and so forth. And on the top, they could see each other's solutions to the problem. We got our subjects through Amazon Mechanical Turk. Because of the synchronous and demanding nature of the task, we gave them a very serious sort of filtering process before they entered the main experiment. We started off with 15,000 single-person instructional trials, then gave them training and filtering tasks, and finally arrived at a 1,620 subject experiment. Our results, in short, were that centralized networks are adaptable to a shifting environment. They showed learning without hurting, and we found support for all the hypotheses we had in our paper. Returning to this ECDF of results, here's the results from the isolates, as I showed you before. Here's the results from the complete clique with the herding and learning effects. And here's the results from the hub and spoke network, the maximally centralized network. There's no herding on the incorrect answer relative to the isolated individuals, but there's a lot of learning relative to the isolated individuals. You've got the benefits of social influence without the costs. Again, we found centralized networks with two-way communication at higher means than controls. They had learning, in other words, a broader spread of the correct answer, with many trials with 7, 8, or 9 people correct at the end, without herding, without having many people getting stuck on the incorrect consensus. But this only worked with the undirected, versions of the centralized networks when there was two-way communication. When there was only one-way communication between the core and the periphery, they did no better than controls. So in conclusion, we found centralization promotes collective adaptability to a shifting environment. The role of the peripheral nodes is to generate independent solutions. The role of the central nodes is to identify and spread those good ideas. The major caveat is that information and influence must flow both ways between the core and the periphery to get these benefits. And as we know, some communication technologies and organization forms encourage one-way flow from the core to the periphery, for example, email or Twitter. And those kinds of sort of centralized networks, centralization in the wild, actually did no better than the decentralized networks. But to get the benefits of centralization, information flow and influence flow must go both ways. Thank you very much.